guess to start, you're going to hear the funny Irish accents. You guys over in Australia will be probably a bit more used to hearing Irish accents than they are over here in New Zealand. But we're two Irish guys that came over here to New Zealand after the earthquakes back in around 2011, 2012, and just never left. In the market over here, there was lots of quantity surveyors at the time. There's not so many Irish quantity surveyors left now. Tends to be the guys who settled down. So I came across in 2012 and worked for 5 years in that kind of construction industry area, and then started up my own business, which is part of the Logic Group now. We're called Logic Cost Consultancy. We've got offices here in Christchurch is our head office. And then we've got an office down in Dunedin and one across on the west coast, kind of it's just starting up across in Greymouth. We're quantity surveyors, we're project managers, the rest of the group has facilities managers, we've got a few draftees, we've got one building surveyor as well in the business. So we've kind of got a lot of expertise across a lot of the professions here. So we can kind of bounce off each other again and play off each other, and when one discipline doesn't know an answer, we typically know it in-house or can go off to external disciplines fairly quickly. Yeah.
That's a really interesting combination, particularly having a building surveyor in-house as well, and as project managers. I mean, you can look at things a bit more holistically than, say, just a quantity surveyor with that single skill set.
That's it, exactly. You know, a lot of quantity surveyors typically are involved in that design stage from a professional quantity surveyor perspective, and then on into construction. Not a lot of quantity surveyors ever see the end user of that building and see how it performs. It's great having the likes of facilities managers on board, because they do see that, and we can often play against them to see just maintenance requirements, life cycle costing, things like that, kind of feed back into what we do as well.
And I think one thing as well that we always say is good here is when you kind of describe the role of a quantity surveyor, often people will say, you know, it's an understanding of architecture, it's an understanding of engineering, it's part accountant, and it's part of a few other different roles all kind of meshed into one. So we have those kind of cross combinations of skills, but usually you're a consultant, PQS, or you're working for a contractor. So what we do here is we do both. So every QS is, you know, spending part of their week doing estimating in an estimating role for contractors. And then we bring that through. So when we're working for our clients as a consultant, we can kind of fill the gaps in a lot easier. We understand in an incomplete design, rather than just going, okay, we don't have enough design, we're going to fall back to square meter data until that design's complete. We can go, look, in our experience, we've seen this enough that we know that there's going to be a steel beam here. So when we look at costs, we can introduce that kind of knowledge. So it's definitely really beneficial for the team to work in both roles often at the same time.
It kind of leads well into, I guess, the point of difference with what we do. We've termed ourselves as 5D quantity surveyors, in that we're kind of branching into a lot of BIM, but it's not. And it's come out of frustration of the existing systems that are out there, and the lack of movement in the BIM, and the lack of the understanding of what BIM actually is, and it's the interaction between all the disciplines and the communication between all of them. What we found is that the existing systems that are out there for quantity surveyors are poor. They're choked off. The potential is there, but it just hasn't happened. What we've done is we found a system that was not used by quantity surveyors, but used more for builders across, with you guys over in Australia. And we've modified and found workarounds with that system to actually build a BIM system that is achievable and scalable. We use that BIM system on everything from the school deck right up to a $100 million hotel that we're working on at the moment. It's so scalable that it's unseen anywhere else in the market in any other discipline, and it all comes out of our measurement process. So we're able to take all of the different disciplines, taking the $100 million hotel as an example. We're able to take all the different disciplines at very earlier stages in design and actually take their models, if they have models, and integrate them into a federated model that we actually do our measurement through. We don't click a button and do all the takeoff of the measures. What we do is, using IFC models, we can get measures directly from those almost automatically using model mapping. But typically what we will do is we'll integrate all of that design information into one model, and then we'll fill in the gaps with our measures. And that's typically that our measures are probably typically 60 to 70% of that model. But what it outputs is a fully federated model that has all the services design, has all of the structural, all of the architectural, which is done through our measurement process, and it spits out a 3D model. One of the great things about that is that it does clash detection. So as we're actually measuring the building, and keep in mind that quantity surveyors have always built in 3D. It's just always been in their head. And it's always been translated back as a bill of quantities or a schedule of quantities to the client. And design teams typically don't want to read them. They don't have the time, they don't have the inclination, and it's not the language that they speak in either. They speak in design, in drawings. So by us in our measurement process actually producing a 3D model, we're now speaking our budgets in a language that the design team actually understand, that the client can see and visualize. And very quickly, it creates that opportunity for conversation. But we do that from the earliest stage of design. We do it at concept design. Rather than doing a benchmark cost per square meter one-page report, our point of difference is that we actually model that building from. Just recently, we had a hand-drawn sketch of a floor plan and a hand-drawn sketch of one elevation, and from that, we actually did a concept design budget. But we did it in a level of detail that the design team could all look at it and say, yeah, look, that's a fair assumption or a fair interpretation of what we were expecting from a structural perspective and everything. It's keep in mind the benchmarking is a huge amount of comparison with all other buildings. What we're saying is we're bringing our knowledge in through efficiencies of BIM. It allows us the time and the efficiency to actually be able to put a hell of a lot more detail into those concept design budgets. And one of the massive benefits of that is the ability then as well to substitute materials. So if somebody comes to us with a concept design, from the earliest stage of that design, we can actually, as quantity surveyors, lead that conversation around, right, well, here's what it will cost on the basis of a timber building. So mass timber, LVL, glulam, CLT, versus a structure steel building and maybe a hybrid building. We're able to model those up once and then swap materials very quickly. The BIM system that we're using automatically understands what those typical transfer of sizes would be across beams, columns, floor sizes, things like that. So it's brought a massive point of difference to us. It's brought a hell of a lot more accuracy at design stage, and it's brought us in as better communicators and better members of that design team. For a long time, quantity surveyors have been kind of partitioned off as being at periphery of that design team, not really given the opportunity. It's often speak when spoken to, so when we ask a question, you'll give us an answer. Whereas what we're saying is we can show through our experience that we can actually build these buildings to varying degrees of accuracy through the design stages and actually be part of the design conversation, adding the value of where we know the cost implications are, but also removing the risk or making fair assumptions where there is risk, and being able to discuss those with design teams.
Yeah, and traditionally, quantity surveying, it can be a risk for projects, but like you're saying, if it is in this building information modeling environment and you can understand prefabricated products properly, then you can see the benefits and measure correctly. So that's a big one. Another one is the importance of having real world data. So you mentioned you've got some previous experience with mass timber projects. Can you tell us about some of your previous projects that you've been a part of?
Oh, do you want to grab that one?
Yeah, sure. Well, we've had one from a few years ago down in Dunedin. Logic were heavily involved from project management as well. And that was a student accommodation building. I believe that was about 3 floors. So that was a large CLT building, CLT floors and walls.
Was at the time and still is the largest CLT building in New Zealand. XLAM were involved with that one. They did all the CLT floors.
Yeah, of course. So, and that was probably one of the earlier examples of what we're seeing a lot more commonly now in New Zealand, where I think one thing Barry will probably mention later, a lot of the mass timber that's been a focus over the last few years has been that kind of architectural tent where we have like Nelson Airport, for example, which is amazing glulam structure, but where our focus has been and what we really kind of see as what is going to drive mass timber use forward is where we see it just replaced as a conventional material in lieu of concrete and steel. So that was a really good example. But now that we're all the way up to 2022, we're seeing that start to be rolled out a lot more, particularly in the aged care facilities. So apartment buildings for those and with office buildings as well. So one of the first apartment buildings then prior to, or post that, that we've been involved in is Clearwater Quays apartment building here in Christchurch. So that project is been completed in a partnership between a private developer and Red Stag Investments and Ministry of Primary Industries in New Zealand. So that partnership is part of a wider group of projects where the data of how building detail, anything from building details to cost, will be made open source for the benefit for any future projects.
That's been a great one for us because it's an architectural high-end apartment building. You're talking about 10 plus million New Zealand dollars. And it used LVL and it used CLT and it used prefabricated wall panels as well. So once we cut our teeth on some other projects, the likes of the Otago Polytech buildings, and we were able to get a huge amount of information out of those ones. This one was kind of more a learning opportunity for everybody that was involved. So the structural engineer was given the time and the fee to experiment with some efficiencies and some theoretical design to see it was the ways of improving steel fixings, was the way to improve efficiency of installation. And from the quantity surveyor's perspective, we've been given a lot of time to actually back cost information that's coming out of it from subcontractors, from suppliers. We've been given the time to look at program in detail. We've been given an education in post-completion benefits of quick turnarounds of buildings. So understanding holding costs and capital investments and things like that. So it's been a great opportunity to understand the holistic view from a cost perspective. And the fantastic thing is that it's open to the market. Anybody can have this information. You can understand how much it costs. You can understand how much each element of that building costs. You can be given the program. We were also given the opportunity and design for a steel version of that building and a concrete version of that building. And again, given the time to actually analyze the exact same things in those buildings and do direct comparisons across elements within those buildings and incorporating program again and understanding what effects different parts of those buildings actually have, so
I think that perspective is really what's the most important thing. You go into a retail shop, you might be looking at two pairs of jeans and you're looking at the price and how they compare to each other. It's just how the human brain works and what we understand. So it's all well and good to get incredible good information that we can use for further projects as a benchmark or carry that data forward for the next CLT build or the next LVL frame. But what people want to know is, well, what would have it cost? So being given that opportunity to look at those two alternative designs, one was full concrete. It was full concrete frame, floors and beams and columns. That got discredited pretty fast in terms of results. But the more common alternative would have been concrete comp floor and steel structural frame. And that was going to be very similar in construction to where we used LVL and CLT, so really comparable. Looking at the perspective, if we were just to compare CLT directly with concrete, you could see that maybe in some cases, and especially if we talk about some acoustics and things like that, CLT would be more expensive. So it's really important that we always look at the total budget, because P&G is right down at the bottom of our estimates and our cost plans and our budgets, and that includes a lot of time. And one of the main advantages we see from a cost perspective of mass timber is how fast you can build in. I think one of the biggest savings we've shown was the floor construction, where that typical comp floor in this apartment building was going to be around a 2-week turnaround, including when we could efficiently work below with propping in place and things like that. It was taking 4 hours to install the entire CLT floor, and we were ready to work on top of that later that day. So the guys would install the full CLT floor, have smoko, take a break, and back into it. We were installing prefabricated composite wall frames on top later that day. So that's where the huge difference is. This
is where a lot of these projects actually fall over, is that you're dealing with a new emerging, I guess it's been around for a while, but for a lot of people, emerging technology or materiality. So what you end up with is, what we've seen in New Zealand, I'd imagine it's the same in Australia, is that for the last 10 years, these timber builds have tended to be the white elephants. They've tended to be the bespoke projects, the passion projects or the legacy projects. People want to build sustainably. They're prepared to pay a premium to do that, and they go ahead and do that. But what's happening is then you've got other developers coming in, likes of housing associations, aged care coming in and starting to look at these buildings as well. Problem is, where they're mining their data from is these legacy projects, which tend to be big architectural legacy projects designed to look amazing and to have a massive functionality that your typical building won't have. But what's happening is quantity surveyors are backcasting these projects, not fully understanding the context of them and trying to assimilate that information to benchmarking assessments of the next building, which may not be anything like it. It's just the volatility around the backcasting information is just huge. It's massive. A lot of these projects fall over, one, because of that volatile information, and secondly, because the people doing the feasibility studies, and I'm not talking about necessarily the quantity surveyor, I'm talking about the developer, the person who gets involved at an earlier stage to make sure that it's actually a runner. They don't incorporate in the program savings, and those program savings have massive knock-on effects that to the delivery of the project that are never considered. It just seems to go over everybody's head. You've got the likes of the market risk, which is huge at the moment. You've got a market that's falling and material increases that are coming, that are skyrocketing through inflation. So the longer that project runs, the bigger risk you're running of that inflation, the property prices dropping, and vice versa. In a market goes the opposite way. You've got risk effectively of property prices skyrocketing, handing projects over later. Those property prices, you're losing out. You're losing out on the potential to move on to the next project. You've also got carrying cost. So you've got the likes of your finance. If you finance the project, so your carrying cost for that. The sooner you can hand those projects over and get your money back, the sooner you're not paying interest on that. Your carrying costs are removed. And then the last thing is your completion settlement. So if you are financing that yourself, the quicker you can return your profits, the quicker you can return your investment, then it gives you another opportunity to get back into that market and start the next one sooner. Again, it kind of ties in with market risk. If you can get out there sooner, well, then your risk is reduced. You got a better perspective on the market. You can see where things are going. You can get back involved quicker. So there's a number of things that have knock-on effect beyond the actual typical quantity surveying assessment. There's all these market investment opportunities and risks that need to be considered as well. So a quicker turnaround of a project gives you a better perspective on those items.
And as well, just on the barriers, I think perception is just a barrier worth mentioning, because and it's what the likes of Clearwater as an open source project is doing to alleviate, because you could have a fully educated design team and an educated quantity surveyor and have all your information done correctly, but the developer who's built for the last 20 years in concrete and steel might just perceive that no matter what you do and how you produce the results, the mass timber sustainable option is always going to be more expensive. And unfortunately, being given alternative designs that are commissioned by the design team and those paid for, and then additional budgets by the QS commissioned, doesn't happen. It doesn't happen. That comes at a cost. So to see how Clearwater stacked up against concrete and steel and concrete alternatives and doing more of those projects, making more of that information open source, that's going to break down those walls and that barrier. And I believe Australia has rolled out quite a large, I think, is it $400 million project for something similar?
Yeah, well, we've got a lot of projects on the go, and that CFC, there's a grant funding for basically green loans, really, for to enable these projects to go ahead.
Yep. And it's the same with the MPI program that we're working in. So beyond the Clearwater project, we're working on a couple of other timber builds. We're in that as well. Most of them are at kind of that concept moving through into preliminary developed design stage. We've got a project, a hotel project down in Dunedin. We've got actually a very interesting one in up in Hamilton on the North Island, where we had a client come into us. They had been out to Clearwater. They had seen some of our presentations, and they had basically a set of detailed design drawings ready to be consented by the authority in Hamilton. They were due to submit that consent application on the Monday, and they came into us on the Friday. We went through our presentation with them again. We showed them what was possible with our BIM systems, taking their existing design and actually remodeling it and just changing up materials to show those comparisons and give them the confidence that there's a level of detail that has been put into these assessments, and that we've looked at all of those external factors like program, incorporated all that in. they went away with that information. They pulled or they didn't apply for their consent on the Monday morning. They took a couple of weeks, considered the information we provided them, came back, completely scrapped the tilt panel, concrete structure and steel structure design, and went back to the drawing board and have started now again a concept design or a preliminary design on a timber build. A bit of a hybrid, so there's some structure steel in it, but there will also be CLT floors as well, and some prefabricated walls. But the amazing thing about this one is that they saw the opportunity and they weren't afraid to actually go back to the drawing board and start again, because they saw the benefits to their broader program of works, get it right the first time. And their intention is that they're going to replicate this all around the country. So it's get it right and then build it multiple times.
They also, what really helped with that dramatic last minute decision making was the opportunity to include 2 extra floors on that building. So to go from a 5-story building to a 7-story building. And I think that's a common trend with why mass timber is selected on a lot of projects at the moment. So we first focused on cost, then largely focused on the upfront embodied carbon, but we most certainly include weight analysis now in all of our feasibility studies, because we can see the impact that those make. We've seen reference projects around the world where towers are being added to with upper floors and mass timber, so we can see the importance of that weight value as well.
That's a really important point. When we output our reports and our designs, even at that earlier stage of concept design, we don't just look at the cost, we do look at the embodied carbon, and we do look at the weight as well. So again, it's all feeding that information back into the design team at the earliest stages of design, so they can make the fundamental decisions that need to be made around sustainability earlier in the project. Because once you get past preliminary design, there's nobody going to go back and redesign it again. Well, it's really rare that anybody will go back and redesign it, or will design it twice, so those decisions around where those biggest savings around embodied carbon can be made need to be made at that concept design stage. It's any later than that, and it's just you've lost the opportunity.
It's for everyone's benefit that it's balanced. So we could design incredibly sustainable buildings, but maybe in some cases let's leave the cross bracing as steel and create a bit of a hybrid. If we create incredibly sustainable buildings and they get shown to always be more expensive because we're not adding a balance with budget, it's not good for the industry. But if we can show that we can build with a very large volume of mass timber at a very comparative cost with traditional concrete and steel, by using some hybrid elements, well, that's what's really going to see it move forward.
And you mentioned before how we can build taller in some cases, so it unlocks a few extra stories. So it sounds like there's a basket of differential value. So height might be one, but it also, the biophilic design and the sustainability impacts. Is it possible to put a number on that? I've heard a few anecdotal ones in the past, like an increase in rental yield or increase in the occupancy or improved occupancy rates and items like this. Are these sort of things, can these be priced in, and do we have any rules of thumb when it comes to that?
I guess in a sense, it's kind of comes from a different industry because it's more your market real estate. But certainly from public discussions that I've heard with people who are from that sector, I've always heard 5% increase on yields thrown out there. It could be higher, but that's just a number that seems to be mentioned quite commonly at the moment. So, over a project. So in this case, that development in Hamilton was, we've added 2 extra floors. So with 3 apartments in each floor, and that is part of a larger development of that building gets replicated 5 times. So what are we looking at there? 30 extra apartments at 5%. And out of the entire total quantity of apartments, 5% extra on each one of those is a huge number. It certainly flips the feasibility to a much greater advantage.
Yeah, it's I guess going beyond the actual the financial part and getting more into the experiential methodologies that go around these timber builds. That's another big consideration that what we found is often is missed or gotten. It's the quantity surveyor design team don't anticipate them or don't anticipate the costs or the methodology that goes with them. One of the biggest parts, obviously, with timber buildings is those steel fixings. we have found that they have been, nearly every project we have been involved on, they've been underestimated, both from a design team perspective and from the QS perspective. The allowances that have been allowed, typically what we've seen in the past, come from the structural engineer will say allow a certain percentage of the cost of the CLT and LVL for these steel fixings. That doesn't work. We need to move towards more a off-the-shelf solution, which is where Clearwater is great. It gave the structural engineer an opportunity to investigate some of those type of details, and I think we're definitely moving in that direction. But what we did with our modeling is we actually we used the structural engineer's IFC and actually identified each one of those fixings at the earliest stage of design that we could, so that we could actually properly count off even the SPAC screws. So your SPAC screws are a huge cost to a project, and people don't anticipate it. So your SPAC screws, we were able to. What we were told was previously there was a rule of thumb used, never ever quantified, and you either over order it and you have too many, or you under order and you have a catastrophic scenario on site where people aren't tracking what they've used and you have a sudden shortage of SPAC screws. We were able to actually model in all of those SPAC screws into our model when we got to detailed design. So we were able to feed all of those material order sheets straight out of our BIM system back to the contractor who was actually completing these, so that they made sure that they had the right number of fixings on site when they needed them. It was huge. And when we used our rule of thumb, we were out by about maybe 25%. When we went and actually modeled it up, we got the number to within, I think, 1% of what was required. So it was, again, just that ability to investigate in more detail, granular information just adds huge benefits. And from our BIM system and the way we do things, it doesn't take too much longer.
Yeah, it gives that confidence. So when we say that this project and the current design of mass timber is stacking up against a more traditional form construction, it's not stacking up because we've missed something. The level of detail in the numbers really speak for themselves. So it gives the client confidence that they're moving forward with the right design, and they have that balance between cost and budget. I think just back on what you mentioned with the biophilic, it's not something that we generally look at ourselves, and I know there's the exposed timber look and being able to touch and feel the timber in a building is something most people aspire to achieve. But, we've kind of been a bit more black and white and clinical about it, in that we're not too worried if it's covered up. We're just simply want to see that material introduced and be a conventional material in lieu of concrete and steel. But there's another side, that if people are well educated in the material itself and just the knowledge that it's there's a story behind it, that's probably adds to that value as well. And it's just that really, where does your concrete and steel come from, and the process and the energy used to make it, versus where does your mass timber come from? Like, two real interesting things are often the timber used to create mass timber is not the grade A timber that's used for your typical framing. Correct me if I'm wrong. So it's not cannibalizing that supply that people are speaking about that's already in shortage. It's actually delivering more timber material for building to the market from a larger source. As well as that, it's increasing the added value within your country that it's actually manufactured in. So you think of what a cube of concrete is timber is to export, versus what the added value is when it's turned into something like CLT. And then, like, an interesting thing we discovered when we looked at Clearwater, for instance, was we looked at the volume of LVL and CLT in that project, and we looked at the harvest yield of timber in New Zealand annually, and worked it back to how much timber is grown on average in a minute. And we discovered that you could regrow all the engineered timber used in that 5-story apartment building in 10 minutes. So that's sustainable.
Yeah, 100%. That is such a strong story there that can get baked in. We've covered such great ground today, guys. It's been phenomenal chatting. Going to the 50,000 foot level. So in your opinion, can mass timber be more cost effective than traditional construction if certain principles are followed? And do we have any ballpark numbers? Which I know it's context dependent with materials changing so much, but do we have any sort of ballpark rule of thumb numbers that you've found from your studies?
Well, with Clearwater, and keeping in mind this is a bespoke project, so it's got that added level of design. But because we were allowed to look at it in that level of detail, we were able to look at every single material and look at the alternative designs in detail as well. We were able to prove that the steel and concrete on that building, when we looked at the comparison across the models, effectively the straight up concrete structure was just redundant. It was from a functionality perspective, it was unworkable. The beams and the columns were too big, and it was just too expensive. When we looked at the steel structure, it came in at about, I think it was about 3% under the cost of the timber structure for this building. But then you start incorporating in your program savings, and you start incorporating those holding costs, market risk and things like that. And what we found was that actually the timber build, because of all those savings, came in cost neutral. And at the time that we built it, the cost of CLT between procurement and delivery actually reduced. So again, if that market cost of concrete and steel is increasing, cost of timber is either stabilizing or it got minor increases, I think, at the moment. It's making it more and more cost effective. And as we move towards that standardization of panel sizes, standardization of steel fixings, it all becomes far more effective and far more economical. On the Clearwater project, the original plan was to actually build two of these buildings, one in steel and concrete and one in timber. They actually scrapped that. They said, we can do this via BIM, and we can do this by getting everybody involved and giving them the time to do it. And yet still get to build two timber buildings, which are better for the environment and prove the point at the end of the day. But one of the important points about it is that having built that first one in timber, I think we were looking at a 10 to 12 week saving. Mm-hmm. That was conservative. They reckoned that if they were to build it again tomorrow on that second site, that it would be somewhere between 16 and 17 week savings. Mm-hmm. And again, you start bringing in those off-the-shelf solutions that we might have in a couple of years' time, and those savings become greater again. So look, the simple answer is we're almost there if we're not there already.
Yep. And just for anyone, who's looking at the price of concrete versus CLT and just focused on that, just in terms of quick numbers, look at what your time cost is going to be with your P&G and your overheads. On a 10 million project, it can be anywhere from $30,000 to $50,000 in a month. It depends what management structure you've set up and how much of a team you have. But it's a lot of the people involved, but it's your site fencing, your security, your site sheds, your facilities on site, your power. But then remember that when you're comparing structure against structure, that's when that core structure is being constructed. So you're most likely in a commercial environment going to have a crane on site, you're going to have your crane driver, you're going to have your dogman. So there's a whole extra cost that can actually double that value. If you started with $35,000 in time related costs, you could add another $35,000 a month for your crane related costs. So if you're looking at $70,000 in this case, just as a rough number example, and you're saving 3 months, please take that into consideration when you're looking at your material costs in comparison to each other. So you have to look at the bigger picture. You have to add those both together holistically, and you'll end up with very, very even numbers on the end of the page.
Yeah, Adam, I think that the biggest problem that the industry has is the misconceptions and the volatile information that's out there around these from both design teams and quantity surveyors.
Education.
It's like not everybody gets the opportunity to do it the way we did it on Clearwater and have the experience that we've had. As a consequence, what we're doing is we're working with a few market players at the moment. We're actually building an application, a web application that will open that information up and allow those comparisons for design teams and for the developer at the earliest stages of design. So you're not going to have the opportunity and you may not have the ability to use BIM. So what we're saying is that we're bringing in for developers a kind of a benchmark application where they can put in the parameters of their project and they'll be given back the comparison of embodied carbon cost across and weight across multiple methodologies of a build. We say if they say it's an apartment block, we'll be able to give them reference models that effectively be just like benchmarking. That's the earliest, that's the feasibility stage of design. But this web application that we're building will be able to plug into the likes of Revit. Basically all your design software will be compatible with this, where as the designers are designing, even at that earlier stage of design, they'll be able to model map via this web application and actually be able to receive live data on the embodied carbon and cost of what they're designing, and it will also prompt some sustainable and cost-effective options. So it'll give you kind of a heat map to show you what areas and what elements could actually be addressed with alternative and hybrid options to actually make your project more sustainable and still stay within your budget. So what we're trying to do is, and it'll be usable right through all the design stages, but what we're trying to do is open up and make that information available to everybody, that you don't need the software, you just use our web application to do it for you.
Yeah, well, that's so exciting. Even if we are cost competitive or, under some circumstances better, no doubt after web apps like that and project teams get, rather than one project under the belt, once you got 5 under the belt, the cost curves seem to be heading in one direction. If people want to find out more about yourselves, this web app, your tools, if they want to get in touch, how do they go about that?
Well, quantity surveying is business as usual is Logic Group, logicgroup.co.nz, and our web application is vquest.io. So it's vquest.io. At the moment, that website is under development, but there is something there with a bit of information. We're hoping to have that application launched towards the middle of this year, middle second half of this year, for people to use. So
for anyone who would like a demonstration and a run through how it works, we have enough functionality internally that we can show working examples prior to release. So there's some contact information on that website, on that landing page.